So for this problem, we're going to be finding the Thevenin equivalent when we have both dependent source and independent source. So we know that we can't directly just get rid of the dependent source to find RTH. So we have to find VOC and ISC in order to solve. So first we'll do VOC, and we can use a loop here and know that we only have I going through here. So minus 20 plus 6I minus 2I plus 6I equals 0. Combining my like terms, let's see, 10I equals 20, and I is going to be 2 amps. Okay, so VOC is going to be the voltage across that 6 ohm resistor. Which is our current, times the resistance, which is 6, which is 12 volts. Okay, so now we want to solve for ISC. So we'll redraw the circuit here. And this time, instead of having open circuit, we will short between those terminals. And our circuit will look like this. Okay, so for this one, we're actually going to use mesh current, and we're going to call this I1, this I2. If we write our mesh on the left, it's going to be minus 20 plus 6I1 minus 2I plus 6 times I1 minus I2 equals 0. Okay, we will also have 6 times I2 minus I1 plus 10 times I2 equals 0 for our second loop. So this is loop 1, this is loop 2. Okay, now something to notice is that the only current here is I1, the only current here is I2, and there is I. So we can use KCL to get a third equation, and we have I1 coming in, I coming out, and I2 leaving. So now we have 3 equations and 3 unknowns. Okay, so now we have 3 equations and 3 unknowns. So we can solve these equations, and we come out with I1 is 40 over 17, I2 is 15 over 17, and I is 25 over 17. Now we know that I2 actually equals ISC. So now we have that VOC. We already solved for that. That was 12 volts. And we know that ISC is 15 over 17 amps. So we can solve for RTH, which is going to equal VOC over ISC, which is 12 times 17 divided by 15, which is going to equal 13.6 ohms. Okay, so our Thevenin equivalent circuit would be plus or minus. So your Thevenin equivalent is going to be that 12 volts and your 13.6 ohm resistor.